Hello and welcome. So let's talk about the traditional ARP. By the way, in the previous session, we have already talked about how the switch does the switching. But basically, the protocol that is runs behind those switches are called the ARP. Okay, so let's talk about first of all the agenda. So first of all, we are going to talk about what traditional ARP is, and then I will be talking about the proxy ARP and gratuitous ARP, but in the next module or the session. Then I will be performing one lab and some common interview question and answers. So as you can see, the tradition are, first of all, let's talk about the definition. The Address Resolution Protocol or ARP is a communication protocol used for discovering the link layered address, okay, such as MAC address table. MAC addresses, okay, associated with a given internet layer address, typically an IPv4 address. So, in short, what it's trying to say, you have the IP address known. For example, we have this one PC which has IP address of 192.168.1.1, and we know that this computer itself knows about the MAC address as well, which is, let's say, AAA. On other hand, we have another PC whose IP address is 192.168.1.2 and the MAC address is BBB. Okay, so this computer, which is B, and the computer A knows about its own IP and MAC address table. MAC addresses. Why am I always saying MAC address table? So they always know about the MAC address. Similarly, the computer B knows about its own IP and the MAC address. But how on earth this computer is going to know about the MAC address of computer B? Okay, but it doesn't know about the IP address, but we are going to ping. Okay, let's suppose this computer A try to ping the host 192.168.1.2. Okay, it knows the logical addressing, but still this computer is short of having or having knowledge, does not have any knowledge about the MAC address of computer B. To know the MAC address of computer B, computer A will send ARP request, which will be broadcast as you can see over here. So this whole story I'm telling you over here. So it is going to send broadcast which will be headed everywhere. But since B will check into the frame and it will look into that, yeah, this is me 192.168.1.2. So this computer B is only going to reply it back with its own MAC address, which is BBB. So next time this computer not only knows about its own MAC address but also the MAC address of BBB in its ARP cache table. So next time when this A wants to send inform a communication or wants to send a ping packet to the B, it will be a unicast packet, and it's one request will go and reply will come back. Okay, so you can read whatever it is written here. So in the next slide, basically I have one demo, uh, which is basically in the animation, then it is going to clear the picture. So as you can see, we have one PC, one whose IP address is 10.1.1 and the MAC address is AAAA. But it is going to ping 10.1.1.3 as you can see. So what happens? It knows immediately, yeah, I'm going to create one frame saying that this is going to be ICMP packet. The source IP address is going to be the 10.1.1. The destination IP address is going to be 10.113. Then source MAC address is AAA, whereas the destination MAC address is unknown. And you know that the unknown destination MAC address means it is going to broadcast this ARP packet everywhere. So what is the MAC address of 10113? To know, it is going to send the packet to everywhere. So only switch 3 is going to reply back because this one is having the IP address 10113, which is this one, but it is 10112, so that is why it is going to discard, and PC4 as well. So only the computer that is going to reply back is PC3. So it is going to reply back saying that this is my MAC address table. Sorry, MAC address. So as you can see, it went back and now it is going to populate this destination MAC. Okay. So now next time, now it has all information. Now it is going to send the ICMP packet and you can see only it is going to receive and reply back. Okay, so that is why, as you can see, the first request timeout, there is always, most of the time, if the destination MAC address is not available in your ARP cache of this PC1, the first packet is always going to be timed out. But the rest of the packets are going to reply back. Okay, so ping is successful. So I hope you get the idea. So let's do a Wireshark demo. And for that, what I'm gonna do, I'm gonna take you to the uh, Wireshark, and then before I capture the packet on this local area connection, what I'm gonna do, I will just go to my command prompt, run as an administrator, and if I'll do ARP minus A, which is going to show me what kind of devices and physical addresses it has mapped into its ARP cache, as you can see over here. And by the way, uh, just a minute, MS Paint. The topology that I am going to show you over here is very simple and straightforward. So we have my PC, whose IP address is 192.168.1.3. It is connected to my router or the gateway, whose address is 192.168.1. Sorry, this is going to be just a minute. Let me remove this one. Okay, so the IP address is going to be 100.3, whereas the IP address for my router or the gateway is 100.1. My router has some MAC address, which I don't know. Even my computer does not know unless until it is having this information in its ARP cache. Whereas the IP address for my this computer, if I can check, how can I check? ipconfig/all, and this is the physical address. Okay, I'm just gonna put it with the 8A and in the end. So whatever in the end, it is going to have 8A. And by the way, in the ARP cache, you can see, if I'll show you ARP minus A 192.168.100.1, this is my router or the gateway whose physical address is 0480 ending with 23. So I'm gonna mention that here as well. So this one is going to have MAC address ending with 23. But um, since this computer already familiar about my 100.1 gateway MAC address, so that is why it is sending the packet as a unicast. So I'm gonna delete or flush out this ARP table. So as you can see, ARP minus D and hit enter, ARP minus A, and you can see everything has been gone. Okay, so what I'm gonna do, first let me check again. No, not yet. So I'm going to very quickly go into local area connection and I have run that packet, Wireshark. Okay, so what I'm going to do again, let's try ARP minus A. Now this time ping 192.168.100.1 and hit enter. Okay, so I sent some ICMP packets. So I'm gonna stop my Wireshark. Okay, and I'm just going to filter out ARP packet, ARP, and hit enter. So as you can see, if I just want to arrange these columns, just click on this resize packet list, and as you can see, it has been arranged. So as you can see, my frame number 9, how much time it took? The source is going to be my 192.168 source IP. If I can show you, sender IP is 192.168.100.3, and this is under ARP, address resolution protocol. This is going to be a request. It is going through from 192.168.100.3, and it also knows about the MAC address. The MAC address of my computer is 8A, which I have already shown you in a MS Paint. Okay, whereas the destination IP I am familiar, which is 100.1, but the MAC address of destination still I'm not aware. As you can see, if this is not aware, it is gonna do what? The broadcast. It is going to send the broadcast everywhere. So it is saying under info, who has 192.168.100.1. Basically, it's asking about the MAC address. Who has MAC address for 192.168.100.1? So this is broadcast. Another packet, you can see this is a reply. So the reply is coming from my sender IP. This time is 100.1, which is what? My router or gateway, and the destination this time is my computer, which is coming to 100.3 back. Okay, now this time you can see the source, the MAC that is coming from the router is C423. Okay, now it got uh, um, the router basically replied back with its own MAC address. Okay, so this is how they are going to um, understand the MAC address of each other, and then they will be able to communicate. Okay, so the packet I sent was ICMP. If I will type ICMP and hit enter, the first one is request, then reply, request, and reply. And as you can see over here, okay, so these are the replies coming. So 192. So this one, being my source, went to the destination. Then from destination, basically it is source my, now this time the source is my destination, and return back to my computer with a reply. And you can see we received 1, 2, and 3 requests and 3 replies. Okay. So this is how ARP works behind the scene. Okay, so with that, our this video is going to come to end, and in the next video where I'm going to talk about the gratuitous ARP and proxy ARP, and then I will perform one lab on packet tracer. Okay, so with that, our this lab is going to end, and I'm going to see you in the next video.